Hi everyone, my name is Thomas Kim. Today is January 31st, 2020. This is my 14th episode about 3D graphics, Intel TVB, OpenCL, Vulkan using Microsoft Visual C++. In this episode, we will implement the C++ parallel algorithm. This is episode 3 about parallel algorithm. This session continues from my previous episode, Parallel Algorithm 2. If you haven't watched my Parallel Algorithm episode 2, this video, please watch them, because my current episode continues from my previous video. In this episode, we probably use std invoke result and is invocable or is invocable R. For more information, please double click this link. Is invocable and is invocable R, is not through invocable, is not through invocable R are introduced in C++ 17 standard. Also, invoke result is introduced in C++ 17 standard. We will be using these type functions in this episode. I probably film how to implement is invocable R in my next episode. Because this session continues from my previous episode, in the download source code section, please double click this link to download the source code from our previous episode. Unzip the downloaded file, rename it Parallel Algorithm 3, copy the folder, paste it to your working folder. This is my working folder. Start Visual Studio Code, open the folder, double-click splitrange.cpp from Parallel Algorithm 3 folder, Ctrl B. If you scroll down splitrange.cpp, you can find the test CPP threading intermediate. Copy this function up to this point. Copy, paste. Scroll up, rename it test CPP threading final. Now copy the function name, Ctrl N, paste it function main, and disable this part. Now start your command prompt, dir cd 14 split range parallel algorithm 3. Hit enter. dir cl ehsc std split range.cpp fe m.exe, hit enter. Sorry, it should be std C++ 17. Fix like this, hit enter. cls. This is the state of our previous episode. Now, in this function, test CPP threading final, scroll down. I will disable this part, Ctrl K, Ctrl C. Now select this part, Ctrl K, Ctrl U. I said this code does not work. Now let's build once again. It does not build. The error message says attempting to reference a deleted function. This causes the problem. std async returns an instance of std future, which is not copyable but is movable. So std move, it should work. In the command line, once again, we build again. Now it builds successfully. Don't forget that std future is not copyable. Now scroll down, select this path. This is reference. I will disable this path, Ctrl K, Ctrl C. Now enable this path, Ctrl K, Ctrl U. This path does not work. It is copy. Okay. Now let's try to build it. Hit enter. It does not work. It should be reference. Okay. We build again. It works correctly. Please keep this point in mind. Future is not copyable. So you have to use reference in this case. Also, in this case, you have to move. Now scroll up. CPP test threading final. I will change the function name. Commit it to your memory. And I will clean up some code. And I will say thread count. You confess thread count here. And I will delete this part. Now scroll down. I will delete this part. Here, put some initialization code for your future if you need to. Now scroll down. I will delete this part. Don't forget, you should use reference to access future. I will copy the function name, paste. We build once again. Of course, it should work. Now we turn this function commit to your memory into a complete algorithm. Copy this part. Copy. Paste. Test parallel algorithm. Now we copy this function, paste it here, and disable it. Template, type name, range type, type name, bin OPR type. Auto is return type, parallel, reduce, range type, start, range type, end. Bin OPR type, it should be forwarding reference, callback. I will put a carriage return here, size t, thread count, -1, size t. If thread count equals size t -1 thread count std thread hardware concurrency auto ranges sprg split range count start end thread count. It should be size t. We need typecast size t. All types should be size t, size t. It is size t. Now we need to have return type of callback using return t decl type callback. We can say size t size t, return t. We test this function like this. We need a callback or a callback. We capture v vector or a start or a end. Double partial sum for or I equals start, I less than end, plus plus I. Partial sum bi times bi. Return partial sum. Now we call this function size t v size. So we passed to size t. First end. Now callback. This is the callback. Parallel reduce. Y is squiggle. Don't forget semicolon here. We are calling test parallel algorithm here. Now let's build. Okay, it builds successfully. Now we need to add up this part. So we need to handle this part. Here we need one more type. Sum up type. Sum up. We have to provide template parameter here. Type name sum up type. Now or sum up or A or B. Return A plus B. Don't forget semicolon here. So we pass this sum up like this. Now in this function, using future t std future return t, using futures t std vector future t, futures t futures. Now we create futures for size t I. We start with 1. I less than ranges size plus plus I futures in place fact std, or we can make block or f std async std launch async. We start our thread immediately. We provide callback. This callback argument should be ranges I first, ranges I second. Now we move std move f. Up to this point, we handled this part. Now we need to call this part. So return t partial sum, or we can say sum of squares. Callback ranges 0 first, ranges 0 second, because it runs from 1. We also have to run range 0. Up to this point, we completed this part. Now this part, like this. For auto f futures, sum over squares equals. Now we use this function, sum up, sum over squares f get. At this point, we evaluated sum over squares. Okay, now we return sum over squares. We can actually use here auto. Now at this point, auto sum over squares. auto root means square sqrt sum over squares. B is the container size. String root mean squares. RMS. And there. We are calling this function. Now we build again. CLS M. This is root mean square. And we implemented parallel reduce. I will copy from here up to this point. Copy, paste, scroll up. We overrode this parallel reduce. Type name, before return, type, copy, paste, before return. Copy this, here, paste. Also note that in this function, we can also do like this. Copy, paste, std, invoke, result t. This callback type is bin operator type. This bin operator type is this callback type. Then size t. This line of code is equivalent to this line of code. Invoke result is introduced in C++17. This type function. I will copy the link and paste it here for your reference. Now scroll down. I will change it. Test parallel algorithm, smarter way. I will copy this function name, copy, paste, disable it. Now here, auto, before return. We capture B, auto, sum of squares, return, sqrt, sum of squares, B size. Don't forget semicolon here. Now I change this font. Root means square. We have to pass before return. Now we don't need it. So this is our final version. We are calling from here. In the command prompt, we build again CLS M. It works correctly. This function. We defined 1 lambda, 2 lambda, 3 lambda, and we passed callback sum up before return. Now I will copy this function once again up to this point. Paste, scroll up. Now I modify it. Container type, container type, container. Now here I will delete this part. Return parallel reduce size t container size std forward bin type callback. One more std forward. Sorry, I have to fix like this. Sum type. Sum up. std forward before return type. Thread count. Y squiggle. Sorry. Type name bin opr type. Now we can modify this again. I will copy this, paste it here. Now we can just pass B. Now we rebuild CLS M. This lambda callback runs in parallel. This callback sum up runs in sequential. This callback before return runs in sequential. As I mentioned previously in my previous episode, I highly discourage creating your own parallel algorithm like this. The reason I discourage this way of implementing parallel algorithm is that, as you can see in this parallel algorithm, we are launching thread. We are launching thread. Threads are operating system kernel object. That is, launching threads is a CPU intensive operation. For maximal optimization, we have to employ thread pool, which I will not deal with. Also, this is thread-based programming technique, which again is not very much scalable. For maximal performance, we have to use task stealing scheduler as implemented in Intel TVB. In my next episode, I will explain how to use isInvocable, isInvocable and how to constrain template parameter types. In my previous episode, only 29 views. The lesser the audience of my YouTube videos, I can film more advanced C++ programming technique. If you like my videos, please give like button. Also leave your comments. If you leave your questions, then I can make better videos. Please subscribe to my YouTube channel. Thank you for watching.